Hello guys, hope you had a good weekend. We're kind of finishing up our unit on functions. We did function arithmetic, we did the difference quotient, which is working with functions and doing some composition and things. And now we're going to look at function inverses. So we need to hopefully get you to understand what inverses are, know how to tell if two functions are inverses of each other, and to find the inverse of a function that's given to you. So there's sort of our three goals. And I have a lot of notes on this before I get to the examples. So sorry about that, bear with me. In general, math is full of inverses. So like positive and negative, add and subtract, multiply, divide, power and root, so like square and square root, or third power and cube root. Even things like fractions and reciprocals. So basically, if two things cancel each other out in math, they are inverses. So functions have inverses too. Instead of just specific operations, you can have a function with multiple operations in it, and they have inverses. Basically, everything in a function and its inverse is somehow reversed, the operations and the order that you carry them out. So if you reverse everything, you essentially get an inverse. Specifically speaking, to create an inverse of a function, or any mathematical relation for that fact, you take the domain and the range and just switch them around. So this example technically is a function. It's not what we're used to seeing, f of x equals, and then there's like a mathematical expression with a variable there. But this is a function. 1 comma 5, 3 comma negative 2, 4 comma 7. Technically, anything that pairs x's and y's together, as long as you don't use the same x value more than once, is a function. Well, you can invert it, and that's denoted by that little symbol there. It looks like an exponent, little -1. You would pronounce this f inverse of x. So this is f of x, f inverse of x. Anyway, the inverse of this function, sorry about that, is 5, 1, -2, 3, 7, 4. You're basically just taking the x's and the y's, or domain and range, and switching them around. The result is called the inverse. Now what's interesting, sometimes if you take a function and invert it, the result will not be a function. But that's kind of just you can ponder that. It's nothing we're going to get into today. Now, if you're given two functions, I'm talking about actual equations now, things like this, and you're asked to state whether they are inverses, you have to do two things. You have to compose, remember that this little symbol means compose, f of g of x and g of f of x. If they both simplify to equal x, then they are functions. But if either one of these does not simplify to equal x, then no, they are not inverses. So I'm going to run through my normal even problems, assign you the odd ones, of two functions, and we have to tell if they're inverses or not. Now in my notes, I used f of x and g of x. Clearly number 2 has f of x and h of x. It's okay, it works the same way. So what I'm supposed to do is I'm supposed to do f of h of x, and I'm supposed to do h of f of x. Compose them both ways, simplify them, and see what happens. If both of them work out to equal x, that's what I'm looking for, then yes, they are inverses. If either one of them does not, then the answer is no. Now I don't know how much room I'm going to need to work, so I'm going to just take it one step at a time. F of h of x means I need to take this function first, 1 minus 4/5 x. Remove the x and put this 4 minus 3x over 4 in its place. Now I need to simplify this and see what happens. So it looks like I'm going to have to multiply top times top, bottom times bottom. So this is going to be 4 times 4 is 16. 4 times 3x is minus 12x. 5 times 4 is 20. How can this simplify? Well, I can split it into 16/20 minus 12x over 20. You're allowed to do that. I can reduce this by 4 down to 4/5, and I can reduce this down to 3x over 5. 1 minus 4/5 is 1/5. And there's nothing else that'll simplify. No like terms, nothing cancels, nothing combines. So the question, did this simplify out to equal x? No, it did not. The fact that that is a no means that we're done. We can automatically say no, these are not inverses. Remember, in order to be inverses, they both have to simplify to equal x. If one of them fails, you're done with your work. So no answers are usually the easier answer to get. All right, let's look at number 4. Are these two functions inverses? So I need to compose f of g of x, and if that works, then later on I need to do g of f of x. But I don't know if that's going to be necessary, so let's see. Oops. All right, f of g of x. So I start with this one first. Negative cube root of x plus 3. Now I made this cube root symbol a little extra large because I have to squeeze that in there. Negative x minus 3 cubed. Okay, so now we got to simplify this and see what happens. Well, first of all, we've talked about square rooting negatives and how you can't square root a negative, that when you square root a negative you get an imaginary number, but you can cube root a negative. It's totally doable. If you do the cube root, let's say, of negative 8. Negative 8 is negative 2 times negative 2 times negative 2. So the cube root of negative 8 is negative 2. It's totally okay to cube root a negative as long as that number, is called the index, is an odd number. You can do negatives. It's only when it's an even number, like a square root, that you get imaginary numbers. So we're safe. We can cube root this. In fact, that negative right there that's highlighted twice in yellow will actually simplify out. So you get two negatives, and the cube root and the cube cancel each other out, just leaving you with x minus 3 plus 3. So you can cube root a negative. It just stays negative. That's why there's that negative there and this negative here. Third roots and third powers cancel out. So what do we have? Well, two negatives make a positive. That leaves us with positive x plus 3. I'm sorry. Fix that. X minus 3 plus 3. Distribute a positive sign doesn't really do anything. It just gives you x minus 3 plus 3. And then minus 3 plus 3 cancels out. So this works out to equal x. So I did f of g and it simplified to equal x. Does that mean that this is a yes, that these are inverses? Not necessarily. We're 1/2 of the way there. It is possible for one composition to equal x and another composition to not equal x. So we do have to do the second composition just to make sure. G of f of x. So I start this time with g of x. That's going to be negative parenthesis x minus 3 cubed. And inside this space here, I need to write that. Negative cube root of x plus 3. So this is what I need to simplify. Well, we can follow order of operations when we simplify this. In parentheses, we have plus 3 minus 3. They cancel out. So I get negative cube root of x cubed. Now, what does a third power do to a third root? Just like before, they cancel out, leaving me with negative x. And then two negatives. Negative times negative equals positive x. So the second composition also simplifies out to equal x. Since, let me change colors here for a little detail. Since both of these equal x, the answer is yes. These two functions are inverses of each other. The second function is the complete opposite of the first function. In other words, everything in one function cancels out the other function, and it does it both ways. So, with a no, when you compose them, they do not equal x. With an yes, when you compose them both ways, they both equal yes. If you feel like you get this, I'm just going to do 6 and 8, so repeated examples. But if you feel like you get this, you can skip ahead till I get down to number 10. Number 10 is going to be a new process. So you'll definitely not want to skip over that. But hang with me if you want to see all the examples. Number 6, are these inverses? So first do g of f of x, or do f of g of x. It doesn't matter which one you do first. I'm going to start with this function right here, cube root of x minus 2, but instead of x, I'm going to plug all of this in. And I didn't give myself enough room. And now I need to simplify this. Well, okay, I can simplify that, and I get the cube root of x minus 2, what am I doing? X minus 2 to the 5th power minus 3. Okay. There's nothing there to cancel out that minus 3. Also, we have a 5th power and a cube root. Remember, a cube root cancels out a 3rd power. What type of a root would cancel out a 5th power? Well, that would take a 5th root. So those aren't going to cancel each other out. You can't even get to this 2 to try to cancel out that 3, and they wouldn't cancel anyway. One option would be to do x minus 2 times x minus 2 times x minus 2. So do this 5 times because it is to the 5th power. Do you want to FOIL all this stuff together? Probably not. So I think we can use a little bit of reasoning and say that when we compose them and simplify it as much as we can, stuff doesn't cancel, and it doesn't look like there's any way for it to cancel if we were to work it out any further. So this does not equal x. Number 6 is a no. Let's look at number 8. So again, we need to compose these both ways. Let's do f of g of x. So that's 2 over x minus 1 minus 1. And where this x is, that space right there, that's where I need to plug in all of that. Negative 3 over x minus 1 plus 2. Okay, this looks like simplifying might be a challenge. So what can I do? I can combine plus 2 minus 1. That's 2 over negative 3 over x minus 1 minus 1 minus 1. Okay. I'm going to write that a little neater. Now we have a complex fraction. If you remember how to work with a complex fraction, you need to multiply by whatever the denominator is. So I'm going to multiply by x minus 1 over x minus 1. Just kind of slid this over to get it out of the way. So on the top, I get 2x minus 2. On the bottom, if I distribute here, that cancels out, gives me negative 3. If I distribute here, it gives me negative 1 times x minus 1. Bring down the minus 1. I can distribute that in there. 2x minus 2 over negative 3. Negative 1 times x is negative x. Negative 1 times 1 is positive 1 minus 1. I can combine this and this. If you're getting lost with this, don't worry about it. Please don't worry about it. You'll see why in a minute. So negative 3 plus 1 is it's going to give me negative x minus 2 minus 1. Let's see. Can I cancel those? No, fractions don't work that way. In order to reduce, you'll have to reduce out of every single term. So I'd have to divide a 2 out of everything. And I can't divide a 2 out of that one. The one that's extra dark because there's no 2 there. These are like terms. They don't combine. Those don't combine. If you try to do anything fancy like I did in the other problem where I split it into 2 fractions like this. So basically I take this numerator and split it into 2 fractions. You can do that. It's allowed. It's a mathematically correct thing, but it doesn't make it simplify or work out in any way. So we've basically composed these. We've done all the math we can possibly do, and this does not work out to equal x. So this is another no. Again, the no problems, okay, I say they're easier because on the yes problems you have to do 2 compositions. You have to do it twice in order for it to work out to be a yes. The no's, basically, once you get started in the composition process, a couple of steps in, you're going to look at it and you're going to say, oh, there's no way this simplifies. I did a whole bunch of extra math steps. They're legitimate steps, but probably right about here, you could say, all right, nothing's going to simplify or cancel out. We're done. This is a no. Okay, let's move on now to finding the inverse of each function. So number 10 right here. For people who have fast forwarded, I'm going to leave this on the screen for just a second so they can see number 10 there, hopefully. All right, so in my notes up above, all I wrote was, to find inverses, there's a 4-step process, see below. So yeah, I don't really have notes on this. I'm going to tell you as I go the 4-step process. Step 1 is basically notation, and it makes things easier to work with. So change f of x to y. It's just easier with all the work and calculations we're going to do to have a y and an x instead of an f of an x and an x. I guess you could say step 1 is optional, but I like to do it. So the first thing I'm going to do is y equals negative 2x plus 5. Step 2, switch x and y around. So this goes back up to when I explained the very definition of functions. Functions is what happens when the domain and range, meaning x and y, are switched. So we actually physically switch the x and y variable around. So step 2, x equals negative 2y plus 5. Step 3, isolate y, or solve for y. Step 3 actually usually has multiple steps. You rarely can just do one thing and you're done. So if I want to do step 3 here, let me change colors to signify that it's a whole new step. In fact, I'm going to change the color over here also. So how do I solve for y? I'm going to subtract 5 on both sides of the equal sign. It gives me x minus 5 equals negative 2y. I'm going to divide both sides by negative 2. And I end up with x minus 5 over negative 2 equals y. Now, there's some issue with having a negative in the bottom of a fraction like this, and also a lot of people like to have what the y equals on the left and the expression on the right. So I'm going to do, how much room do I have? I have a lot of room. Okay. I'm going to do something a little special here. So I'm going to rewrite this y equals x minus 5 over negative 2. And just very often to deal with a negative down here, I don't know if this is what the answer key is going to say. Very often you'll see multiply by negative 1 over negative 1. Negative 1 over negative 1 doesn't change the value of the answer because negative 1 over negative 1 is 1. You multiply something by 1, you don't change its value. You just change the way it looks. So if I multiply the top by negative 1, I get negative x plus 5. And if I multiply the bottom by negative 1, I get positive 2. So I end up with y equals negative x plus 5 over 2. Honestly, this is correct, and I have no problem with it, but this is something you would see in like other math books. If you take this in college, if you maybe on the ACT, you might see this type of an answer not be present on your choices if it was the ACT has a multiple choice test, but the right answer would look like that. So that's a little trick you should know how to do. It may or may not be relevant all the time. All right, anyway, step 4, I'll switch back to blue. Step 4 basically reverses step 1. You're going to change y to, now not f of x, but f inverse of x. So your final answer comes in step 4, f inverse of x equals negative x plus 5 over 2. Now, this little bit that I did here may not have been relevant in this problem. It's possible the final answer actually looks like that. So when I scroll down and check it, we'll see number 10. Where am I? Good grief. I haven't checked anything, have I? So check number 10. Oh, wow. They did it even completely different. So let's talk about that answer. And then I got to go back and check. See, I had no, yes, no, no. Wow, I totally forgot that. All right, let's talk about number 10. Okay, so that's real easy to get their answer. So basically, Both of these terms in the numerator are over 2. So you can write this as negative x over 2 plus 5 over 2. So you can split it from one fraction into two fractions. Then negative x is the same thing as negative 1x. So negative 1 times x divided by 2 can be expressed as negative 1/2 x. And just bring down plus 5/2. And then that's the answer. So what we have is 3 different ways to represent the answer. And I can actually think of a 4th way. So this could have been done, step 4, f inverse of x equals x minus 5 over negative 2. So that could have been the answer as well. Don't get too bummed out or discouraged if you do it all correct and check yourself and the answer is slightly different than what you expected to see. It'll be okay. All right, number 12. Let's, again, find the inverse doing this 4-step process. Oh, you know what? No, I forgot. Sorry, I was going to check what I forgot. No, yes, no, no. I'm pretty sure we're right. No, yes, no, no. Just to be consistent, I always want to check my answers on these worksheets when I do them, these lessons. Okay, number 12. So step 1, y equals 3/8 x minus 3/2. Step 2, x equals 3/8 y minus 3/2. Step 3, I'm not going to keep changing the color. I just wanted it to be clear that step 3 includes potentially a lot of work. So I did it in a different color. But here, oops, found a mistake. So switch x and y. That means that's supposed to be a y. So step 3, isolate y. So I got to go through whatever steps I need to. I'm going to rewrite it here. Okay. Do you see how there are 2 fractions here? There is a cool trick when you're solving an equation to eliminate the fractions. Just make them completely go away. And this is called clearing the fractions. So you need to ask yourself, what is the common denominator for 8 and 2? What is a number that 8 will divide into and 2 will divide into? There's lots of numbers like 16 or 32, but 8 is the lowest common denominator. You can divide 8 by both of those numbers. So take that common denominator and multiply it by the whole equation. We're going to do one big distributive property. Over to here gives me 8x. Over to here, it actually cancels out that 8 and gives me 3y. Over to here, it cancels out the 2, but it leaves me with a 4, right? 2 goes into 8 4 times. 4 times 3 is 12, minus 12. Now there's no fractions left, and it's going to be easier to isolate y. So the next step in isolating y is going to be to eliminate that minus 12. So I'm going to add 12. 8x plus 12 equals 3y. Finally, I can divide by 3. And I end up with y equals 8x plus 12 all over 3. So step 4 is to write this with the f inverse notation. F inverse of x equals 8x plus 12 over 3. Now I'm going to guess that their answer on the answer key doesn't look quite like this. They probably split it into 2 fractions, 8 over 3 plus 12 over 3, and then simplified it. Now you can't simplify 8 over 3, but you can rewrite it as 8/3 x. You can simplify 12 over 3. 12 divided by 3 is 4. So I'm guessing that is going to be the answer when I check myself. What was this? Number 12. Oh, and they wrote it backwards. Okay, whatever. This is right, but just for the sake of argument, they wrote their answer like this. No particular reason that it has to be that way. Totally okay either way. Even this one is a right answer. Ultimately, I mean, if there's something that can be simplified, you have to simplify it before you call it your final answer. But the form you leave it in really doesn't matter a whole lot. Yeah. It's just, well, so you know that our tests are multiple choice. If you leave your answer like this on a test, and that's not one of the choices, you're going to have to know that this choice is equivalent to that choice. So some of the work I've done here is important for you to follow along and understand. All right, let's look at number 14. So to find the inverse, change it to y equals 3 over x plus 1 plus 2. Step 2, switch it. X equals 3 over y plus 1 plus 2. Step 3 is where all of the work happens. So I'm going to give myself a little more room. I'm going to duplicate that here so that I can start my work. I need to isolate y. First thing I'm going to do is subtract 2 on both sides. X minus 2 equals 3 over y plus 1. Now, the next step is potentially complicated, but it doesn't have to be. There's two ways I can explain it. I think the best way, yeah. All right, so I want to isolate y. It is not doing me any good being underneath a fraction bar. I do not want it there. So to get it gone, to cancel that out, I would have to multiply by the whole quantity y plus 1. To cancel out y plus 1, you have to multiply by y plus 1. But, of course, what you do on one side, you have to do on the other side. So you put this in parentheses and do times y plus 1. So what does that give me? It gives me y plus 1 times x minus 2 equals 3. Now you might be wondering, why did I not FOIL this all together? If I FOIL that together, I'm going to get an xy somewhere in my answer and then a minus 2y. How am I going to isolate y if I've now spread it out into multiple terms? So in a problem like this, you do not want to FOIL that together. If you don't FOIL it together, what do? Well, again, the goal is to isolate the y. So how about if I divide both sides by the quantity x minus 2 in order to cancel that out? So I get y plus 1 equals 3 over x minus 2. Now, isolating y is simple. All I have to do is subtract 1 on both sides. And now you can't combine this minus 2 and that 1. The minus 2 is in the denominator of the fraction. All you can do is, rewrite this as 3 over x minus 2 minus 1. And then step 4, f inverse of x. Or not f, this one was actually h in the original problem. So if it starts out as h, it should finish as h inverse. H inverse of x equals 3 over x minus 2 minus 1. Okay, there is a potential alternative answer, and I hope they didn't go any further with this because really that's enough work. And there it is. Okay, let's look at 16. Not trying to rush. You can always pause. You can go back and rewatch something if I went too fast, but I don't want this video to last an hour either. Okay, step 1, y equals x minus 2 cubed minus 2. Step 2, x equals y minus 2 cubed minus 2. Step 3, oh, what am I doing? Oh, step 3, oh my gosh, I totally lost track of what I was doing. Step 3 is to isolate y. So I am going to copy this. Yeah, my brain just skipped a beat there and it confused the heck out of me. Okay, I want to isolate y. Step 3 is all about isolating y. So how about I start by adding 2 to both sides, cancel that out. I get x plus 2 equals y minus 2 cubed. That's good. Now, to isolate y, I need to somehow cancel out that third power. Do you remember from a little while ago, what does it take to cancel out a third power? Where was it? We just did it. Right here. A third power and a third root cancel each other out. So, let me get back to this. Too much scrolling up and down. It's making me dizzy. To cancel out a third power, I need to do a third root. And I think I need to give myself a little more room to write. So here goes. So, I need to do the third root of this side to cancel out the third power. But that means, of course, I have to do the third root of the other side. In math, in algebra, what you do to one side of the equal sign, you do to the other. So that gives me the third root, or cube root, as it's sometimes called, equals y minus 2. The root bar goes away along with the third little symbol there, the 3 symbol, and the third power. So that all goes away. Now, is y isolated? Not quite. I need to add 2 to both sides to cancel that out. You can't add this 2 and this 2 and get 4 because this 2 is sort of locked in under the radical bar there, so you can't really touch that. So it's just cube root of x plus 2 plus 2. The second plus 2, just make sure it's not underneath that radical bar, equals y. So step 3 is done. Y is isolated. Step 4 is to rewrite your answer. Is it f? No, this one's g. G inverse of x equals the cube root of x plus 2 plus 2. Okay, cross our fingers. Let's check and see if that one's right. Number 16. There it is. Cube root of x plus 2 plus 2. All right, number 18, and we are done. Find the inverse. Step 1, y equals the negative cube root of x plus 1. Step 2, x equals the negative cube root of y plus 1. Step 3, isolate y. So how am I going to isolate y? I think I'm going to start by subtracting 1. That cancels that out. I get x minus 1 equals negative cube root of y. What do I do with this negative sign? Well, you divide by negative 1, cancel it out, and then you have to divide this side by negative 1, and you get negative x plus 1 equals the cube root of y. Is y isolated now? No, we got to cancel out the cube root. You do that with a third power. Now we have to do the other side with a third power. Put this whole thing in parentheses, raise it to the third power. This cancels out, and we get y equals the negative of x plus 1 cubed. Step 4, this was f of x, so our final answer is going to be f inverse of x equals negative x plus 1 cubed, or potentially the answer might be 1 minus x cubed. These may be inverted just because something about starting with a negative x, I don't know. Maybe not. One of these two has to be the right answer. Let's check what's the last one? 18. Oh, that's way different. It's still right, but wow, how would they get that? Let me come back here. So definitely minus 1 on both sides is your first step. Oh, I know. Okay, what you could actually do is you could do the third power on both sides now. You get x minus 1 equals, the third power cancels that out, and you're left with negative y. Then divide by negative 1. And so this whole thing divided by negative 1 just makes negative x minus 1 cubed equals y. And so f inverse of x equals negative x minus 1 cubed. Okay, so what we're seeing is that on many of these problems, there are multiple ways to express a correct answer. And I have multiple students. There's like 50 or 60 of you guys. So chances are a lot of you are going to have answers different than the answer key. So I'm going to say this. If you can make your answer match the answer key because you understand the additional steps that'll get you there, fine, do that, please. If you know that your answer is right, you know that your answer is equivalent to the answer key, you just don't want to write down the extra steps, that's fine, I get it. When you get the right answer, keep it, even if the answer key is different, if you know that it's the same. If it's something like x plus 5 here and the answer key is 5 plus x, you don't feel like going back and changing your answer, well, duh, don't waste your time. If it's a significant difference and you're unsure, then on this assignment, post something in the comments or email me and say, look, is my number 12 correct? Or let's say number 11. Is my number 11 correct because it doesn't match the answer key? Then I'll know I need to take a look and address that specifically. Now with like 60 some of you, I hope there isn't like everyone has 2 or 3 of these, because I'll be up all night trying to answer these questions. Hopefully it goes over pretty well, but if it does not go over well, for sure let me know. This is the type of thing that if we were in a normal classroom, the day that this homework is due, before you hand it in, I would work out problems on the board and answer everyone's questions before you have to turn the paper in. That way you're 100% confident in your answers. So it's just one of those things that this whole online format doesn't work that great. So hopefully you can get the right answers, air quotes, right answers, but understand that your different answer may still be right. You just have to ask me about it. Okay, I feel like I'm rambling. I'm going to stop there. Good luck on this. Please do contact me with questions. I look forward to hearing you.